I'm Rob. By day, I'm a software developer at Metaswitch Networks in London. By nights and weekends and any other time I get, I'm the Sippy maintainer. I have been since late 2012. So I'm going to give you a bit of a talk about Sippy and some other sort of tools in that space. It's been a long conference. We're a day and a half in, so I thought I need to get you excited about my presentation and remind you why you care. And it's pretty easy to care about this stuff. I think one of these points will apply to almost everyone here. You're either writing software that needs to perform well, maybe you're running services that will get bursts of traffic, registration storms, maybe you just want to make sure that you're giving good audio quality to your users, and there's lots of reasons to do performance testing, there's lots of reasons to care about performance test tools. So what I'm going to cover is SIP performance testing with Sippy. That's going to be a big focus. Seagull, which is a similar alternative test tool that can do other protocols. I'm going to talk about a bit about how to integrate these tools into bigger test suites, run them automatically, format the output, and then if we've got time at the end, I'm going to talk about something called JSippy, which is my recent, slightly experimental project to fix some of the quirks in Sippy. Quick show of hands, who has used Sippy in the past, that knows what a scenario file is? Good. That means I can run through the first bit quite fast and not be as worried about running over time. So what I'm not going to talk about is functional testing. The tools for performance testing are not as good for functional testing. If you care about that, I've got some other thoughts on what's good there. Talk to me afterwards. I've already talked to Andreas about what he should do to test Kamailio. I've talked to Matt about the Asterisk test suite, and how to talk to Alex about good functional testing. I'm not going to talk about IMS performance benchmarking because it's hugely complicated, and I suspect only a relatively small proportion of you will care. So Sippy, almost all of you know this. So you describe your call scenario in XML. You can run a huge amount of calls with it. It's incredibly efficient. I've easily got it making 5,000 calls a second, and you can then get useful statistics out, success rates, response times, and failure rates. This is what a Sippy XML scenario file looks like. If you can't see it at the back, you've got an XML element scenario for the name, then you've got a send element, you've got the SIP message you want to send out with some placeholders like remote IP, remote port to get filled in, and then you've got the things you want to receive, so receiving 100 trying, which is optional, 180 also optional, 200 OK, which is not optional for a successful call, and that's the basics. If you weren't familiar with Sippy before, that's what it looks like. When you run it, you get output like this. This is running at 6,000 calls a second, just to show I wasn't lying about how efficient it is. It shows you successful messages, retransmissions. If any had timed out, or you got a 400 instead of a 200, then you get that in timeout or unexpected message. With the right command line options, it can show you print out CSV log files. I've imported those into OpenOffice just to give you a flavour. So this is saying, target rate 6,000 calls. This is the rate actually achieved, it's a bit below that. You can also get response time statistics out, so you can see what your post-dial delay is, how long your calls take on average, how long they take to hang up, whatever you care about. So that was, as promised, the whirlwind tour of Sippy. For large-scale signaling testing, it's pretty good. It's probably the best tool out there, but I'm biased. RTP support is not as brilliant. You all saw my dangerous demo earlier. So it can send RTP traffic, but it doesn't do, for example, jitter calculations on the RTP traffic it sees. It doesn't give you packet loss statistics. But when I talk about JSIPP at the end, I'll talk about some of the stuff there. Scenario model is a bit inflexible. I'm sure anyone who's used it might have experienced problems with registering and then receiving a call which doesn't fit that neatly into its scenario model. And even though it does print out these CSV log files, parsing is tricky. If you're running a test for a long time, your disk will fill up. And this is one of the issues I've seen occasionally, and I'm going to talk about it at the end when I come back to JSIPP. So Seagull, like SIPP, it's invented by HP probably about 10 years ago now. While I took over SIPP from the HP guys, I don't maintain Seagull, but I think it does have its own relatively active maintainers. And it works on similar principles. You define your scenario in an XML file, and then it runs at quite high loads. But unlike SIPP, this is multi-protocol, so you can do diameter and HD48 maybe code, which, as certainly protocols, probably ones you care a lot about. It can also do TCAP, radius, probably a couple of others, I'm guessing. Whereas, obviously, SIP is a textual protocol, so you just basically write your SIP directly in your scenario file. Seagull is a little more confusing, so you have to have XML. This is XML that describes a diameter message. So you say, my diameter command, here are my attribute value pairs, some are just strings, some are hex. And then to receive a server assignment answer, it's a bit simpler. So the nature of diameter as a binary protocol is that it doesn't lend itself quite as well to being written down in textual scenario files, but it's perfectly workable. And the same thing, this is MegaCo, that is textual. You can see the MegaCo text here. I don't do a lot of work with MegaCo, so I'm going to move past this one quite quickly. And that's a moment of Seagull. So if you haven't heard of it, but you need to do any sort of diameter testing, MegaCo testing, I recommend you take a look at it. But just running these things from the command line is not necessarily the easiest thing to do all the time, particularly if you want to do continuous integration, have this stuff run automatically, have it pass the results, email them to you, it's over the threshold or something. You do need more of an automation layer around it. And this slide basically gives you the ways you can automate your SIPP or Seagull load testing. So there's CSV injection, and what this basically is you can give SIPP a CSV file, and every time it makes a call, it will move down one line in the CSV file and populate some of its parameters from that. So if you've got 10,000 users and you want to simulate SIPP making a call from each of those, you just give it a CSV file with 10,000 usernames, and it would do that for you. Control sockets are interesting. I didn't know about them until I took over SIPP and dug into the code a bit. So hopefully they'll be new and exciting to you as well. So Seagull listens on a HTTP port, SIPP on a UDP port, and you can send in commands. So these two examples of commands that will increase your load. If you want to simulate traffic spikes, you can run SIPP or Seagull to fairly low load, send in a command to spike up the load quite dramatically, run like that for a bit, and spike down the load at the end. So you wouldn't need to stop and restart your scenario manually. You could do this overnight with a cron job or some other automation script as part of continuous integration testing. In terms of getting results out, I've already talked about the CSV log files, which will give you call success rates, the response times, call length, post-hour delay, whatever response statistics you need. And recently I've added support for SIP error codes. So if you want to make sure that when your system's overloaded, it correctly sends you back 503 service unavailable and doesn't start sending back 404 not found or 487 transaction not found, then you can check that and make sure that in error cases you're returning the right errors. And if you need any more flexibility than that, Sippy has an exec action which lets you run arbitrary shell commands. So if you need to stop in the middle of your test run and make a HTTP request somewhere for whatever reason, part of provisioning, part of a change in your Kamailio behavior, then you can do that and essentially implement arbitrary behavior. I don't think Seagull has the same action. I didn't see it when I skimmed the docs. So if you're using diameter, you might have to write that yourself, but you're capable of that. And so this is just a quick diagram of how you might write that sort of integration framework around Sippy. So you create your subscribers, however you do that, and put them into a CSV file, which would then feed into Sippy, so it would generate calls to or from all those subscribers. If you want to do any changes in the middle of your test, such as ramping up the call rate, then you'd feed that through the control socket, and that again affects Sippy call generation, and then just spews out log files, which you can use for custom reports, pass them into user interfaces, whatever you like. So that's what's out there at the moment. That's the stable, battle-hardened, well-tested stuff. Now we're on to the more experimental bit. So Sippy is quite an old code base, quite a large code base, but a relatively simple tool. It clocks in at about 21,000 lines of C code, or C++ code, which, Kamailio is 830,000 or so, I think, a talk yesterday said. So not huge by comparison, but huge for what it does. I got sick of people coming to me with feature requests, and I just couldn't be bothered to go through all these lines of code to add things. There are no unit tests, I wouldn't know if I'd done it right. So I said, what happens if I can just start from scratch and I know what I'm doing, just do it as simply as possible. So in January I started a Java rewrite. It's now working, it makes calls at a similar rate, interprets the same scenario files, but it's about 1,500 lines of code. Any of you who've ever developed software will know how much easier it is to add to a 1,500 line program than a 21,000 line one. So I predict good things from this. And yeah, as I say, it should be basically the same for most users, same XML files, similar performance. The first improvement I've made is to get rid of the log files and the slightly aged Encurses UI. What I'm doing instead is every time a call finishes, or a message comes in, or an unexpected event happens, or receive times out, I send a message over 0MQ. 0MQ is a messaging protocol, very similar to MQP, and it's just a publish subscribe model to whatever subscribers say, I'm interested in this Sippy's events. And this means you can then build anything you like, web interfaces, native GUIs that will just subscribe to this event stream, parse it however they like, drop the messages they're not interested in, and it makes Sippy more of a platform for writing test infrastructure around. And now you don't have to keep around these log files, you don't have to do CSV parsing, and your test infrastructure isn't a second-class citizen just working off the log files. This is the same infrastructure I'm writing to use the standard UIs. And as a proof of concept, what I can do, I knocked this up in a weekend. I can't show it to you for real, but I got a screenshot. So this is just streaming all the Sippy events to a web server, which then streams over WebSockets to the browser, which makes nice graphs out of them, successful calls in green, failed calls in red. And you know, I'm not saying that this is what you must use, this is just an example of the sort of thing that's possible now, but it definitely looks a lot nicer than the console-based UI. This is just updated diagram showing how this changes things. You should just skip the log file stage. You're now having Sippy feeding directly into your custom report for your UI. I've had some questions, particularly since coming here, about why on earth I chose Java, and a bit of skepticism. So this is a slide just to address those concerns. The big thing is the existing C++ code isn't going anywhere. It's well tested, it's 10 years old, it's battle hardened. It's a bit clunky to add new features to, but if it works well for you, if you don't need the new features, then you've got no need to worry. Just keep using that. But Java has a lot of benefits for this sort of thing, particularly because I want to develop rapidly. I want to prove that these sort of new features, and the new features I'll talk about in the next slide, are easy to develop. I'd quite like to have a higher level language than C or C++. I don't want to do manual memory management. I've done that. It's really boring. It creates lots of bugs. You really don't want bugs in your test tools. So Java, garbage collection, excellent. But Java's about as fast as C++, or not that much slower, which is why I chose Java rather than Python, Ruby, one of those things. Java's got a lot of libraries. Part of the reason Sippy is only, or gsippy is now only 1,500 lines of code is I'm building on existing SIP parsers, I'm building on existing RTP parsers, building on existing network libraries, which is why I've been able to get it to this phase as fast as I can, working in my spare time. And looking to the future, one of the interesting things about JVM is that there's lots of other languages than Java running on it and able to interoperate with Java libraries. And what I'd like to see in the next few months, what I'd like to experiment with, is making the core of Sippy more of a library and being able to have JRuby, Jython, Groovy, these sort of much faster JVM scripting languages, being able to create Sippy scenarios, run Sippy tests, as an alternative to the, again, slightly clunky, slightly dated XML files. So you might be skeptical of Java, but I think it's got promise, and I urge you to wait and see. If you're not skeptical of Java, great. I just want to talk a bit more about the features I'm hoping to add. So better RTP testing is high on my list. I've got sort of half a prototype that analyzes RTP streams and prints out jitter statistics at the console. I just need to tie that all together and print it out over 0 and Q. And I think that's going to be really useful for a lot of testing, particularly of SBCs or things that do media relay, just to see how jitter gets affected, how packet loss gets affected when you've got high loads. I'd like to make the scenario model more flexible. I've had a lot of pain in the past, trying to register a Sippy instance and then receive a call. The fact that the call IDs aren't the same, but the scenario model requires the same call ID, just causes a lot of pain. I want to make that better. I'm still working out exactly how without making the interface horribly complicated. If you've got ideas on how you'd like it to work, then grab me, that'd be great. And obviously one of the big themes here is WebRTC is the future, etc., etc. It'd be nice to have test tools for that. And there is a Java API for WebSockets, so I'm going to try and tie those together and let you do SIP over WebSocket, performance testing with Sippy. These are just my ideas. I don't know the whole industry. I don't know your personal project. If you have a pet peeve with Sippy that I can make better, then come and tell me. There's a coffee break coming up relatively soon. I'm open to suggestions. This is the documentation for mailing lists for everything I've talked about, and I will leave that up while I take questions.
Thank you. Thank you very much. Now, any questions? On the front, maybe? You have a question?
I'll ask the right question. Yeah, thank you for that, Rob. That's all very worthy stuff, but something's kind of puzzling me, and that is, you graduated with first-class degree in ancient and modern history in 2011, and here you are doing SIP testing. What happened?
So that's a lesson for everyone in not giving out your LinkedIn profile. There's not a lot you can do in ancient history. I liked software. Metaswitch were very good, and like a lot of Metaswitch employees, gave me a job without having to have a computer science background. Here I am. I'm sorry I'm not a museum creator at the Pergamon Museum, but
Well, clearly,
it's probably good for you that I'm not.
Clearly Metaswitch spotted something, and it's great to have you doing this stuff and not being a curator. Thank you.